So now that we have learned three models, which one should we use? Well, it depends on the context. Say you want a fast calculation, right? You do not care about the accuracy, then you should go for the ideal model. And if you want very high accuracy, then you should use the voltage source plus resistance model. The calculations will be a little more complex, but you will get more accurate result. But if you want something in between, we will use the CVD model. But in our course, we will mostly use the CVD model. We will sometimes use voltage source plus resistance model, and sometimes we will use ideal diode model, but we will mainly use this model. So let's see an example. So this is the same circuit from the last lecture. So a 5-volt voltage source is connected in series with a diode and a resistance. So we are asked to find the V0 and I0 using the three models, the ideal diode model, the CVD model, and the CVD plus resistance model. Well, we are given that in case of CVD model, the value of VD0 is 0.7 volt, and in case of CVD plus resistance model, the value of voltage source is 0.7 and the value of resistance is 10 ohm. So let's see one by one. Well, in case of the first case, the ideal diode, well, let's first say that the diode will be on, right? Because 5 volt, 0 volt, the current will always try to flow in this direction. So the diode will be on in all these cases. So in case of ideal diode model, since the diode is on, we will replace it using a short circuit. So since this node and this node is shorted, the V0 will be 5 volt. And the current through the diode and the resistance can be measured from the current through the resistance. Now for the resistance, the voltage of this node is V0, which is 5 volt, and the voltage of this node is 0 volt. So the current will be 5 V0 minus 0 divided by the resistance, so which is 2 milliampere. So you see that using this model, the analysis is very easy and the calculations are very simple. Now let's see what happens when we use the CVD model or constant voltage drop model. So if we use this model, our results will be a little bit more accurate. So this is the case for CVD model. Since the diode is on, we have replaced it using a voltage source of 0.7 volt. Now we cannot say that V0 is equals to 5 volt. Why? Because it is not shorted. But we can easily find V0. Why? Because we know when a voltage, if we have a battery with V0, this means that V0 is equals to the voltage of positive terminal minus the voltage of negative terminal. So here 0.7, it means that the voltage of positive terminal, which is 5 volt, minus the voltage of the negative terminal, which is V0. So from this equation, we can easily find V0, 5 minus 0.7, it will be 4.3 volt. Now we can find the current using the previous method. The current through the resistance will be V0 minus 0 divided by the resistance, which is 2.5. So if we calculate this, the result will be 1.72 milliampere. So if we compare these two results, so we see that the voltage is very much different, right? It's 5 volt and 4.3 volt. The current is also very different, 2 milliampere versus 1.72 milliampere. So these are very simple to calculate but not very accurate, and these are a little bit more complicated, but they are more accurate than the ideal diode model. And let's consider the third case where we consider both the resistance and the voltage source. So since the resistance is 10 ohm, it can be written as 10 divided by 1000 kilo ohm, which is 0.01 kilo ohm. So what we do is we replace the diode using a voltage source and a resistance 0.7 volt and 0.01 kilo ohm. Well, now we cannot simply find the V naught from this circuit. We have um, uh, uh, we cannot write the 5 minus V naught is equal to 0.7 because there is a resistance. What we have to do is we have to use KVL, Kirchhoff voltage law, to first find the I naught. So if we write KVL equation along this line, we can write as the starting node voltage 5 is equal to the voltage of the voltage source plus the voltage drop across the resistance, which is 0.01 I naught, and then the voltage drop across this resistance 2.5 I naught plus the voltage of ending node, which is 0. So from this equation, the only unknown is I naught, and we can easily find I naught, which will be 1.713 milliampere. And what about V naught? Well, V naught is the voltage. So we can, since it is the voltage, we know the current through the resistance. So we can write the V naught minus 0 is equal to I naught R. So if we put the values, it will be 4.283 volt. So if we consider these two results, the results due to CVD model and the results due to CVD plus resistance model, we see that the values we have found are quite close to each other. 4.3 versus 4.28 and 1.72 versus 1.713. These values are fairly close to each other. So there is very little accuracy we gain by using CVD plus resistance model. So we will mainly use these two models, CVD model and the ideal diode model.